Hello, and welcome to our introductory course on data clustering. This course starts with a review of the data science workflow, what is cluster analysis, some simple examples, and the data clustering workflow. It then follows with the fundamentals of data clustering, including a review of the main distance and similarity measures, a taxonomy of the clustering algorithms, how to represent and evaluate clusters. The way that I organize this topic to cover here today is we are first going to have an introductory part in which I'm going to present the data science workflow. Then I'm going to present a concept of what is cluster analysis, some simple examples just for us to grasp the idea of what we are talking about. And then I am going to present to you the data clustering process, which is pretty much standard in most of my presentations. I try to put together the process with which some specific task occurs. In the second part, we are going to talk about the fundamentals of data clustering. This is because in order to understand how to perform clustering, we need to understand what are the main distance and similarity measures, how the clustering methods are classified or categorized, how we can represent the clusters, and there are many different ways of doing that. Then how we evaluate the result of a clustering algorithm. And finally, we are going to present some sets of clustering algorithms divided into partitional clustering, density-based clustering, and graph and hierarchical clustering. So let's jump into it. Here, in this first part, I want to briefly discuss with you again the data science workflow. If you see many of my courses in some of the series, I talk about this workflow because it helps us to understand how the field is organized and in which step of the whole process we are at the moment, we are presenting now. The first step is basically the understanding of the problem that we have and what types of analytical solutions we can develop to the problems that we want to solve. And it also involves designing the use cases and defining what are the requirements that we need to develop these solutions. The second stage is basically data collection and data preparation. This is a crucial step because it is in this step that we prepare the data for analysis. And the third step here is what I call data analysis. And by data analysis, I mean the application of techniques that allow us to extract insights, to characterize and to understand the data, but they do not involve any specific learning. All the learning algorithms are applied in the data analytics step, which in principle should be performed after the data analysis step. But it's true that in many cases, the authors and the scientists and the analysts, they just skip this process and go straight to the machine learning step, which is a data analytics step. And finally, after we do all that, we have to validate our solution. And this means to assess quality, to assess quality in terms of accuracy, in terms of speed response, and in terms of generalization capability. And after all that is validated, then you do integration. You integrate your solution with the system or whatever you're working with. So what is cluster analysis? Well, when we think about clustering, we are basically talking about how do we organize a set of objects or a set of items based on their internal or intrinsic characteristics. This is different from classification, for example, because when you do classification, you have a previously defined label, and your goal is to take an object and to assign that previously defined label to that object. But in cluster analysis, you don't have that label in advance. And this means that you cannot build a predictor to classify your data. Instead, What you have to do is you have to find and group similar objects together. This seems to be a not so profound difference, but in fact it is, because one thing is to develop a model that is capable of classifying something based on a set of data that is already pre-classified. And if you ask, well, but if the data is already pre-classified, so why do I need the learning algorithm? And the reason why I need the learning algorithm is because I want to extrapolate, I want to generalize that knowledge. And to do so, we have to build a model that is capable of learning from that labeled data and extrapolating the classification or the prediction for the new data. But in the case of clustering analysis, as we don't have the desired data, the desired label or the desired target for each object in the data set, what we have to do is to search for similarities and or differences between the objects that compose the data set. And cluster analysis includes a wide spectrum of methods that are applied to analyze multivariate data, which means data that is described by many variables, with the goal of discovering groups that are called here clusters. And the idea, the intuitive idea, is that objects belonging to the same group, they are more similar to one another than to objects belonging to different groups. Well, let's have a look at some very simple examples for us to understand that. Here we have three different data sets. In this first data set, when we look at it, we can see an ellipsoid with a number of squares, but there is no apparent separation between any subgroup of objects. And this is different, for example, from this set, in which we can clearly see two subsets of a higher density of objects, and they are separated by a space with very low density or no density in this case of objects. Okay, so these are what we could call Gestalt clusters, which are clusters that we can clearly see, and this is also called natural cluster. So a natural cluster is a cluster for which we can clearly see a difference between the objects that compose each of the clusters. Okay, so we have regions, here we have regions of high data density separated by regions of low densities of data. There are those spaces here. Well, another simple example, and then I've got a question to ask you, but the first thing is we have a set of 6 balloons here, and the question is, how would you cluster or organize these balloons? We can think at least of 2 different ways of organizing these balloons, right? For example, here I have 2 round balloons with this balloon with a different shape, and here we have 2 balloons with a different shape and 1 round balloon. And the main difference between these 2 groups is that we can say that this is the group of small balloons, whilst this is the group of big balloons. And the question is this clustering correct? It depends, right? It depends on which features you're using or which is the most remarkable feature for classifying these objects. When we look at this other clustering, I can ask the same question. Is this clustering correct? And when we look at this clustering, we can see that the feature that determines these clusterings is the shape instead of the size. So we have 3 round balloons, a bigger one and 2 small ones. And here we have 3, this specific shaped balloon, and with different sizes. But in this case, we can clearly see that the shape was more relevant for the clustering than the size. Okay, so, and the answer to the general question is, well, both clusterings are correct. And another question that you may ask yourself is, okay, but which feature will the algorithm privilege? Is it going to be the shape or is it going to be the size? It depends. In principle, we don't know which feature is going to be privileged by the algorithm in advance. We'll have to run the algorithm so that after the algorithm gives us the result, we are able to say what were the features that defined the way that the objects were separated into the clusters. just to finish this introductory part, let's have a look at the data clustering process. In most cases, any data analysis and data analytics process will have a data processing step in which we'll have to take the raw data and to prepare it for analysis. And this means, for example, to find and replace missing values. This means to normalize variables such that all of them have the same range or the same domain. This means if you're dealing with text, for example, you can make that all your text is in capital letters or all your text is in small letters, right? So any type of data preparation is called data pre-processing, and it's part of the first step here in the data analytics process. Well, the next step is very peculiar for data clustering because the next step involves defining the similarity measure or dissimilarity measure. And the reason why we have to define this measure is because, as we said, as we don't have a target class or a target goal in my test, what we have to do is we have to search for similarities among objects in the data set. And to search for these similarities, we will need a similarity or a dissimilarity measure, because if I calculate the similarity, I can estimate the dissimilarity, and vice versa. If I calculate the distance between objects, I can estimate the similarity as, for example, the inverse of the distance. The smaller the distance, the higher the similarity between a pair of objects. So this is a very important step that we have here in cluster analysis. The third step is to run the clustering algorithm itself, and then we have to represent the groups. And that's something very important because we can represent a group by simply presenting the set of objects that compose that group and saying, well, this is one group. But I can also use, for example, one object that represents the whole group, and we call this object a prototype. But I can also use a subgraph or a subtree that represent a group of objects. So there are different ways of representing groups of objects, groups or clusters of objects, and we are going to see some of them further ahead in this course. And finally, we have cluster evaluation, which means I have to assess, or I have to evaluate the quality of the clusters that I found. And this is something very interesting because if we think about the essence of clustering, which is to place similar objects together and separated from objects that belong to other groups, I have to think about ways of evaluating the internal characteristics of the groups. And we will discuss that also in the next topic. Thank you for watching and see you in our next class.